Hey, everybody, welcome. It's Friday. we got Robert from Omaha. We got Steve. You are the man. Good morning. Good morning. Good morning. What I have been, you know what? I can't explain. Today is busy. Laurel, welcome. I have to close some files because I have been working on an upcoming NEMA Codes and Standards meeting is coming up. I've got a TIA I want to try to get adopted. They're shortening up the 2029 code cycle. So they're going to be having they're going to have public inputs earlier next year. So that means I gotta step up my game. I am just, I'm overwhelmed. I am overwhelmed. Nihad, correct me if I'm wrong. I think we have our paper done, right? I mean, our presentation. I think we're good. The next step is the article. So I just want to make sure of that. Anyway, Mark, good afternoon. Mark Rogers, thanks for joining in. And we've got Laurel, thank you for joining in. And we've got Steve, you are the man. You are the man. And we've got Robert from Omaha. Thanks for joining in. Okay, so let me go to my website. Let me go. I've been using, I don't know if you guys, I hope you guys like it better, but I've been using my website a lot more this year. I plan on using it a heck of a lot more for things like this because I redid my site. But my wife, Bobby Joe, has a website called twoadorable.labs.com, and it's a blog, and she blogs, I don't know, weekly, daily, I don't know. She's always over there typing. So I set up my, gosh, Neds, shortened the NEC 20, yeah, Nihad, they did. So I rearranged but I'm waiting on your input. I sent you the update. Oh, I thought we were done. All right. I will look for it. Thank you, Nihad. So I changed my website and I made it like a blog. So now when I go to, I don't know if you guys have ever done this before, but when I go to WordPress, if I go to WordPress on my site, I can go to posts, and the posts are the, come on, it's thinking. These are my posts. So I can create a post. I can add a new post. I can copy a post. I can create, like I got my TD Comics coming soon, and I have 7 published. I have 2 drafts that I'm working on, and I can schedule them. Like one of them is Electric Shock Drowning, a Preventable Tragedy. I plan to release that one, I think, somewhere probably in May. I can't remember. Maybe that's Electric Safety Month. That one is I got DC Power Distribution is in draft. That one is going to be scheduled to be released. So I work on these things, and I do some information, and then I release them. So because I've converted it now to a blog type of website, I have a little bit more flexibility and I can use it a lot more. It's not just an information thing. So when people subscribe to it, they'll get the notifications whenever I post. So one of my posts, and what I'm doing is I'm trying to drive our discussions for Fridays off of this, and I'm putting the questions up here. There we go. So these are questions on the table. I just got another one today, which is related to the fault current question. I might, it's a short circuit current rating. just got off the telephone, literally, moments ago about a short circuit current rating question. And I relayed some of the challenges that I've seen in like elevator control panels and things like that. So we had some code changes. And I keep getting these questions. I've got existing equipment. How do I handle this? How do we address the short circuit current rating of existing equipment? And what is the hazard? What could happen? Things like that. So in any case, check my rings. I'm going to check my rings. Look at that. I'm checking my rings. How many steps? You know how many? Oh. Do you know how many steps I've had so far? Dismiss. I'll tell you how many steps I've gotten sitting in my basement. Does anybody else manage their step or watch their steps? This is going to be embarrassing. It is 12 o'clock and I've only got 1,093 steps, 0.51 miles, and one flight of stairs because I came down. Actually, I should have 2 flights because I came down from upstairs. Anyway, here's the question. We can touch base after you're live. Yeah, I should be available, Nihad. I've got a call. I'll take a look at my calendar. But I believe I have a call. All right. So, questions on the table. Maybe this has been said, but I think that boat hoists are different from boat lifts. So both terms should be included and defined. This was on my Marina discussion. Marina Del Rey. There's a song, Marina Del Rey. What is that song? It's ringing in my head right now. Marina Del Rey. Article 555. Article 555. Actually, do you know what we can do? Boat lifts. Here, I think I can do this. All right, yes, I'm in NFPA link, and I'm going to do boat lift. I'm going to go back to here. This is the nice thing about NFPA link. You go to this location, okay? And you go to boat lift. Now, what it'll do is I can include enhanced content. I just now saw that. I did not know that I could exclude it, and I can exclude it. Select publications. I think I can select all publications, can't I? Publications. Matching codes and standards. I don't want to do select publications. I don't want to limit my scope. I'm not going to put those in. I can do that, I guess. These are all my favorites. I'm going to do a view all. How do I show count results? You know what? Before I could search all codes and standards. I could search them all. I don't know. Have you guys seen this before? Have you seen an issue with this before? I was always able to search all codes and standards. Boat. Codes and standards. Here we go. All right. Here it is. Okay, so I'm good. Boat lift. So I'm going to do boat lift, not loft. Boat lift. So boat lift, the question was, Tom, I'm saying this to, no, boat, maybe this, but I think the boat hoists are different from boat lifts. I'm not seeing boat lift. Boat hoist. Boat hoists are in 555 and in NFPA 70, Article 220. If I just search for boats, Boating facilities, boat launch, boat slips. This is in 5,000. So hoist. I'm just going to search for hoist. Cranes and hoists are in 610. Boat hoists. Ooh, boat hoists. 555. Hoists and elevators. All right, so now let's do this. Let's do a search for Webster Dictionary. Definition of boat lift. I am going to allow a boat lift. That's AI. Collins, I need Merriam. My buddy Merriam. A boat lift. Bar lift. Boat lines. Bar lifts. Boat knots. I'm not seeing boat lift. How about boat hoist? Boat hoist. Boats. Boom hoists. All right, so boathouse. Botanist. Tattooists. Let's use one word. Boat hoist. Boaties. Booties. Boat shoe. There's no boat hoist. So here's my perspective. Here's what I'm thinking. We use boat lifts. Boat lift, yeah, exactly. It's not in... the word lift is, and the word hoist is. Let's look at hoist. The definition of hoist is to lift or raise. To become hoisted, rise. Hoist as a noun, the act of raising or lifting. So the word lift is in the definition. If I put in lift, it says to raise from a lower position to an elevated position. Boat. I don't see anything that says hoist. I don't see the word hoist used in boat lift or in lift. Control F. Hoist. Yes. So lift. An apparatus or machine used for hoisting, such as a set of pumps used in a mine, elevators, an apparatus for raising an automobile as for repair, ski lift. So maybe this has been said, but I think that boat hoists are different from boat lifts. So both terms should be included and defined. I think boat hoist is one of those things where you put your boat in the slip and then lift it, hoist it out of the water for whenever it is not in use. The lift brings the boat up and out to be stored elsewhere. So here's my thoughts on that. When I look at NFPA 555, you know what? The other document is NFPA 303. So if we go to 303, so if I go to NFPA 303, which would be another good reference. Hey, David Engelhardt is in the house. If I'm in 303, I'm going to search. They use the term hoist. David, we are talking about hoists and lifts. NFPA 303 uses the word hoist. There's a marine hoist. They only use the word hoist. Let's look at lift. And they have a crane, which is a mechanical device used for lifting or moving boats. Battery tongues or other approved carrying devices shall be used when removing or lifting batteries. So, let's take a look at how do we use the term in the National Electrical Code, boat hoist. 555.35. So I knew, for some reason, I knew GFCI was going to be at the heart of this discussion. It always is. It always is. The reason I think is because we have a requirement, boat hoists, in 555.35C, Charlie. GFCI protection for personnel shall be provided for outlets not exceeding 240 volts that supply a boat hoist installed at docking facilities. And I know exactly where this is coming from. If I say it's not a boat hoist, it's a boat lift, it's semantics. I would look at the words and determine what's the difference between a lift and a hoist if they're doing the same thing. We could rewrite this. We could say, GFCI protection for personnel shall be provided for outlets not exceeding 240 volts that supply equipment used to lift or hoist boats. Period. And it doesn't even need to say out of the water, into the water. If you have a piece of equipment that raises a boat, I could call it a crane, right? So this is the challenge when you're writing language, when we use terms and we don't define them. I'm telling you, I have learned to gain a respect for Article 100 definitions. This is a good example. David, we need to work on a public input. Or do you think that people are removing GFCI protection because they're calling it a boat lift instead of a boat hoist? That's the fundamental question. If people are interpreting it correctly, the way it's supposed to be interpreted, then have at it. So I would say to the gentleman or lady or whomever it was that submitted this question or said that both terms should be used, I would say if you're going to make a public input, you could make a couple. You could say bolts that supply boat hoists, boat lifts, or boat cranes installed at docking facilities. You could also rewrite it to say 240 volts that supply equipment used to raise boats at docking facilities. Make it more of a generic, instead of trying to use a term, boat hoist, describe the action. So that's the other thing you can do, is go to the definition instead of going to a term. Use what you would use to define a boat hoist and describe what's going on. That probably is better code language, especially when you don't have a defined term. That's my opinion, and I'm sticking to it, because remember, everything on my channel that comes out here sometimes started up here, but it's always from the heart. I'm trying to help, and it's the least I could do, because I do the least that I can do. And I stole that one from Palmer Ekman. Okay, so for electrical safety purposes for persons, your substitution with the word equipment is ideal, as it covers anything in this special location in 555. Yeah, I would agree with you, Steve. That's, in fact, I didn't know I said equipment, but yeah, that would be perfect. You're right. Equipment and describe the function. Yeah, and you know, part of safety is enforcement and making sure we all interpret the language the same way. I don't have to agree with the language, but I at least want to be consistent. You know, it's sort of like when you're disciplined and you get yelled at for something. And you say, well, I may not agree with what I'm getting yelled at for, but you didn't yell at me when I did that over there, and now you're yelling at me for here. Why are you yelling at me? Because you're changing the rules on me. having the rules be consistent is a good thing. Unless, of course, I want to leverage the gray areas. We should call this session Leveraging the Gray Areas. All right, so this one here, I thought I answered this, but the individual texted me and said, you didn't answer all of it. So on a previous Q&A Friday, we went through this. It says, I'm sending this text because I know you're busy. I have a question about GFCI. What are the load side conductor length limits? And we went through that, remember? And honestly, I was just, even after this one, I got into the same discussion with someone else. And in my opinion, that's a fallacy. Anyway, for a Class A GFCI, in other words, at how far away do you lose effective GFCI? Blah, blah, blah. The question, comments in the threads with the group moderator, and apparently this was and group expert, only generated more questions. The expert and moderator both said 240 volt GFCIs can run farther than a single pole with neutral. Is that true? I would say no. Again, you have to, this is my opinion. I'm giving you my opinion. Based upon the functionality, think about what GFCI is. A ground fault circuit interrupter, the Gazaltas have to equal the Gazintas. Whatever goes out the hot, got to come back the neutral. And if I have two hots and no neutral, remember that current, it's AC current, so it's going both ways on those two conductors. Any current that goes outside of the normal path, if it exceeds the 4 to 6 milliamps, it's going to open. It's an unforgiving technology. It doesn't care where it's going. So whether it's 240 volts and going further, I mean, can I go further on a 240 volt circuit? If I had a 15 amp circuit and if voltage drop is my limitation, then yeah, my circuit can be longer just because of voltage drop, but not because of leakage current. If I have a circuit, here's my logic, and again, if you disagree, you disagree. If I have a circuit so long in length that when I touch the hot conductor, less than 4 milliamps flows through my body and out a different path, it won't trip the GFCI, but then also I will be able to let it go because that's the let go threshold, 4 to 6 milliamps. So if I have a very long length of run and I touch the hot conductor and more than 4 to 6 milliamps flows through my body, if there's enough voltage at that distance, right? Because that's the other issue, is what's the voltage? If there's enough voltage at the end of that run to push more than 4 to 6 milliamps of current through my body, the GFCI is going to trip. It's a current function. The current that flows in the circuit is dependent upon the impedance. But if I add so much impedance that I'm below 4 milliamps, what's the hazard? I'm going to go, ooh, that wasn't good, and I'm going to let it go. Anyway, so on that second question, I would say I don't believe it's true. In my opinion, I would argue against it every day of the week, twice on Sunday. Could I be wrong? Hey, we all could be wrong. Would I grab that conductor? Probably not. Dawn is saying, hold on, Dawn. I want to get the whole question up here, or the whole statement. I think the point is that the leakage on ungrounded conductor is canceled by the leakage on the other conductors, with those two summing to 0 in the CT. It's a theory. I have never seen it in practice. In fact, Dawn, if you watch that other Q&A Friday, we have a real world scenario of over 1,000 feet of conductor. over 1,000 feet of conductor that the manufacturer that they use said will not work on a GFCI, and it works perfectly fine. The leakage currents aren't going to cancel. Do you realize? I just don't agree with it, Don. That's just based on my experience and my knowledge of these applications. I don't believe that would be the case. And I would say, prove it. Put it in, go out and do the cancellation. Show me the, don't show me an equation. Because here's the issue I have with the aspect of an equation. In the example that we had in the ballpark example, where we had over 1,000 feet of conductor, there was a very smart and good engineer, did a lot of math, and proved without a shadow of a doubt that it will trip on leakage currents, capacitive coupling leakage currents at distances greater than 250 feet, I think it was. And this was over 1,000. And his opinion was, this will not work. It will always trip. They fixed the problems in the circuit. It is working today, in the rain, during every event. The handheld indicator trips the GFCI. It functions perfectly. When I started down that road, I called a testing agency, a very well-known testing agency, the individual who was responsible for that technology, and his comment to me was he heard people make those claims, but he has never seen ever an example of it in practice. It's easy to make the claim. It's easy to go through. And in my opinion, on the equations, you've got to be very careful, because when you're trying to model a real world situation, your impedance values and the way you draw the circuit and the way you formulate your mathematical equations may not match the examples exactly. So in theory, sounds great. In practice, I have never seen an issue. I can't fathom an issue. So that's just my opinion. Advertisements. I don't know what I'm not trying to advertise anything. Oh, I get you. Sorry about that, David. Hey man, I'm just trying to pay for the equipment. Leakage on one ungrounded conductor. On one ungrounded conductor. Yeah, you're talking. I have not seen any leakage on an ungrounded conductor enough to do anything. So, if you have measurements, I'd love to see the example of where this occurred. I could give you an example of where I'm pushing over 1,000 feet of conductor to operate measurement equipment in a ball field, catching people come across the finish line. GFCI protected. It works solidly. It was tripping. The manufacturer was recommending to remove the GFCI protection instead of demanding that the installation be reviewed for accuracy. The inspector took the approach of requiring them to fix the wiring issues. They used the wrong wire. They didn't use the right terminations, the whole bit. When they fixed all those problems, it is working today. All right. Steve. The canceling was the rest of my previously texted GFCI question. Has another person alleged that double pole has less nuisance because of canceling leakage? I agree with you, Steve. I would disagree with that. I agree with your position. I think you're thinking logically and you're thinking in the correct direction. I would support you on that. I'm going to continue on. The moderator claimed, okay, let me just do this back. L1 leakage, canceled by L2 leakage. I don't agree with that. I said that the ground is effectively in parallel and that flow would be a function of resistance as current takes all paths. You are a smart man. That scenario of simultaneously an equally faulted circuit to ground is highly unlikely. You're absolutely right. The moderator also stated that the GFCI doesn't measure individual per leg current or compute anything, but measures the secondary current on a zero sequence CT, and if it's above a predetermined value based on the turns ratio, the GFCI trips. I always thought that the GFCI tracks the magnitude of current directionally, consistently compared flow. It is a zero sequence CT. I would agree with that language. It's a zero sequence CT. We put all of the conductors where everything needs to stay in the path in those conductors. Think about what has to happen to have leakage current going from the ungrounded conductors to the grounded conductor. Because if it goes outside the path, it's going to trip. If it goes over the equipment grounding conductor, it's going to trip. You would have to have the current going out the two blacks, coming back the white. If there's leakage between the two, they're still all in the path. If you touch that conductor and it goes to ground and it's greater than 4 to 6 milliamps, you're done. It's going to trip. If it's not greater than 4 to 6 milliamps, it's not going to trip. I don't know. Anyway, the GFCI doesn't measure individual per leg current. Okay, we read that. I have always thought that he had stated that in support of his saying that the GFCI would measure 0 amps leakage current if L1 and L2 were simultaneously leaking 2 milliamps. If it's leaking current to the equipment grounding conductor, and the equipment grounding conductor is not going through the zero sequence CT, that means the Gozaltas aren't equal to the Gazintas. It's going to trip. Main question above about length limits and single versus double pole performance are not well understood in the industry. I would agree with that because of the very limited number of comments on my posted question in a group with 70,000. Typically have 300 to 500 comments post. I think the most are waiting some authentic answers some people might have watching this. I agree. In my opinion, I think that there is misunderstanding on this. I think that I could probably generate an equation that'll show that you're going to have issues, but we need, I think, better testing or more testing to show the practical nature of it. Verify through test. He said if it goes L1 and L2 to ground equally and simultaneously. Well, if it goes to ground, Steve, it's outside of the path. Even if it's equal. L1 and L2, if I have 30 amps going out, 30 amps coming back, and both of those leak to ground 2 milliamps, that's 4 milliamps. Or say, I can't say 2 milliamps. It says 2 milliamps each. That's 4 milliamps. Still not enough to trip a GFCI. Say it was 6 milliamps each, and I had 12 milliamps of leakage current. I've got 12 milliamps of leakage current. So it's going to trip. I'd love to see the test. You could set this up. All you got to do is put a resistor out, take a length of run of conductor, take an impedance and put it between each of the phases to ground to pull 2 milliamps. 2 milliamps each is only 4 milliamps total. It's not going to trip a GFCI at 4 milliamps. Remember, the threshold's 4 to 6 milliamps. You need around 6 milliamps for the let go threshold anyway. So 2 milliamps each, that's ain't going to happen. You need more milliamps. So that's my opinion, and I am sticking to it. Okay, Next question, fault current question. How low do you go? How far down in the power distribution system are we required to calculate fault current? Hold on. We got Mr. Gannier. He is saying that the currents are 180 degrees out of phase and some to zero at the CT. So it doesn't see it. So you're saying if I have a ground fault on phase A and B, on the two hots, which are out of phase with each other by 180 degrees, if I have current test it. Take two conductors, put the exact same resistance to ground on both conductors because they're out of phase with each other because they're two different phases. So what you're saying is, Tom, that won't add up because exactly the same amount of current's going to flow through those resistors and it won't trip. The GFCI won't know that when I have two hots go into the equipment grounding conductor, because they're out of phase with each other and an amp flows this way and an amp flows that way, it's not going to trip. I don't know that I agree with that, Dawn. I don't know that I agree with that. They would have to have. I just don't see it. I just can't. I just can't see it. I apologize. I just don't agree. I don't know. I love this discussion. The point is that the two faults are so highly unlikely to be exactly simultaneous and equal. I don't disagree with you there either. I'd love to see it demonstrated. And Steve says, I would love to see the proof too. Yep. It's easy to make statements. It's easy to make a statement, but it's harder to prove. And if it's really hard to prove, you have to really question, is it even practical? I will look into it. I don't know. I'm not even going to waste my time. Anyway, fault current question. Fault current question. How far down in the power distribution systems are we required to calculate fault current? All right. I like this question. The reason I like this question, I don't get it as often as I probably should. I'll tell you a scenario that I just had with an individual. I couldn't even tell you if I wanted to who it was. But we had a discussion, and I can't remember if it was email or if it was, I think it was voice. But if the question that we were talking about was in the 2026 code. In the 2026 code, Dawn, wait, hold on. Dawn says there's a 2024. Oh, so they've got test data. So Dawn's saying they've got data and it's going to be in ECNM. I would love to see it. I would love to see it. I would love to see the real world example that might be, it says in August 2024. So I'm looking forward to seeing that proof. Because remember, We can talk all we want, and everybody's has an opinions. Everybody's got an opinion, and they're just like whatever, and I'm just saying. All right, so fault current. The individual I was talking to, we were talking about panel boards, switchboards, and switchgear, and an arc flash label that's required. And his comment to me was something along the lines of, does this mean we need to calculate fault current to a disconnect switch? Or I can't remember what it was. No, I know what it was. It was the marking. It was in 408. There is a new code requirement in 408 that the panel boards, switchboards, and switchgear, here it is. The short circuit current rating of switchboards and panel boards at nominal circuit voltage based on the overcurrent protective devices that are installed shall be field marked in a readily accessible location on the enclosure. And you're also required to put the available fault current on the enclosure. So we were talking about this, and they said a comment, something about the next thing we're going to have to do is know what the fault currents are at a receptacle. And I said, receptacles have a short circuit current rating too. And they said, no, they don't. Yes, they do. Anything that carries current has a short circuit current rating. And if you apply a receptacle beyond its short circuit current rating, that's just as much of a problem as applying a circuit breaker outside of its interrupting rating or a panel board outside of its short circuit current rating. And then the discussion was, well, we don't look at fault currents at these devices. And I said, well, you're probably safe because if you're at a receptacle in, say, a dwelling unit, and that receptacle has a 2,000 amp short circuit current rating, you're not going to have 2,000 amps of short circuit current, available fault current. But you take that receptacle and put it next to a panel board, right next to a panel board, that maybe has 22K breakers in it and has a 22,000 amp short circuit current rating because the available fault current at that panel board is very high, then that receptacle could be exceeding its short circuit current rating, so somebody has to verify that the receptacle isn't exceeding its rating. And I think a bell went off during the conversation that I never thought about that. And my comment was, yeah, we have to review and understand that. Now, I may elect to only go down so far. For example, if my available fault current, if I calculate my available fault current at the secondary of a transformer, and it's 1,000 amps or 2,000 amps or less than 10,000 amps, and everything downstream is 10,000 amp short circuit current rating or interrupting rating, then I technically don't have to go any further because I know my available fault current is only going to be less because of the added impedance. But if I have receptacles, and I've never done this calculation before, if I've never taken a number 12 or a number 14 and thought about what is the available fault current based upon a run at the source that I need to worry about whether or not that receptacle is rated correctly, then I should at least do it once to get the feeling. So it is our responsibility to make sure that the short circuit current ratings of components and the interrupting ratings of overcurrent devices aren't exceeded. I don't need a code requirement to tell me to calculate fault current in a power distribution system. It's like saying you need to put the date. You need to put the date on your smoke detectors when you replace the batteries. I don't need to say you need to have a pen or a magic marker to put the date on. You can't put the date on without the magic marker or whatever it is that you're going to write. So if I tell you that you need to make sure that the short circuit current rating of a component is not exceeded by the available fault current, I don't have to tell you have to know what the fault current is, because how else are you going to determine whether or not the component is overdutied? So how far down in a power distribution system I go is not driven off of a code requirement. Now, the NEC it requires switchboards, switchgear, and panel boards to be marked with an available fault current. So if it's a panel board, I would say out of those three, the furthest down in the system is going to be a panel board. It's not going to be a switchboard. You don't have a panel board feeding a switchboard. You have a switchboard feeding a panel board. So if every panel board has to have the available fault current marked on it, and I don't have elevator control panels, I don't have industrial control panels, then the furthest I go down is my panel boards as required by the code. But for me to determine whether or not the receptacles and all this other stuff, if I don't already feel comfortable that the available fault current at that receptacle on the wall doesn't exceed, if I feel comfortable that it doesn't exceed 2,000 amps, in my house, I feel very comfortable that I don't have 2,000 amps at that receptacle. I don't have 2,000 amps at my main panel board. So I know for daggone sure I don't have 2,000 amps at my receptacle. Okay? So do I need to do a short circuit study and verify? No. I had it when I knew what the fault current was at my panel board, because I know it's going to be less. And if it is within the rating of all equipment downstream, I don't need to go any further downstream. David, I got comments. I'm sorry. I'm talking and I ain't watching. Calculate fault current to the point you result with less than 5,000 amps. That's a good philosophy. That's a good philosophy, David. I don't necessarily disagree with you. Laurel, 408.6. 408.6, yes, it's short circuit current rating, and they're changing it, Laurel, in the 2026 code cycle. Let me look at what's 2020. 2023 says 408.6. 408.6 says in the 2023, it says switchboard, switchgear, and panel boards shall have a short circuit current rating not less than the available fault current. That whole sentence is covered by 110.10. All of my components have to have a short circuit current rating not less than the available fault current. The second sentence says, in other than 1 and 2 family dwelling units, the available fault current and the date the calculation was performed shall be field marked on the enclosure. Now they're modifying that in 2026, Laurel, to require a short circuit current rating to be marked on the panel board or switchboard, not switchgear, because switchgear comes factory marked regardless of what you put in it. And the short circuit current rating of your switchboard or panel board is going to be dependent upon the interrupting rating, the lowest interrupting rating of the overcurrent device is installed. And it tells you that the marking should comply with, and it says the available fault current calculation has to be documented and made available. So you need how you came up with those numbers. And then it says when modifications are made, so they added this, when modifications are made to the electrical installation, that the available fault current at the line terminals of the equipment, you have to redo those and redo the evaluation and redo the calculation. So, Laurel, there's a lot coming in this regard to 2026. Carl Lewis, can a GFCI AFCI combination receptacle detect a line-to-line fault? GFCI definitely not. If it's a line-to-line fault, ain't gonna see it. Now remember, line to line, the moment you bring the ground in, now it's going outside the path. But line to line, not a ground fault. An arc fault will only detect it if it's an arcing fault. So Carl, if I take two wires and I if I short them, geez, I'm looking for the words. If I take a wire nut on it and I short it, which I did once, on the advice of an electrician friend of mine, there was a pair of conductors I pulled out of the ceiling, and all the breakers were off. And I was putting things back, and he said, do me a favor. I said, what? He goes, you know those two conductors? He says, short them and put a wire nut on them. And I was like, well, why? He goes, we don't know what breaker those are off of. And I was thinking that they were just wires that were abandoned in place. And I said, well, those are wires that are abandoned in place. He goes, we don't know that. And I said, well, that's a very good point. So I did exactly what he told me. And there was one breaker inside my panel board. The moment I closed it, it opened. And I knew exactly what circuit that was. And then I was able to fix the problem. But that electrician was a very smart dude. So AFCIs are only going to detect an arc. So if you short a line-to-line, if you do a line-to-line fault, that AFCI is not going to detect it. Plus, if for me to have a line-to-line, that would have to be a shared neutral application, right? So I'd have to have a two-pole AFCI, and it would have to be a shared neutral application. All right. Carl, thanks for joining in. That's the first time I've seen your name in here. So good question. Thank you. David Engelhardt. Now, I can't locate the reference that states all equipment is to be rated at least. No, you know what, David? You're thinking. Here's my opinion. I believe you're thinking of circuit breakers. All circuit breakers that are not labeled have a 5KA IC, and that would be in Article 240. Article 240. It's simple and free, something special. 240 is for you and me. In Article 240, we have, I'm going to look in the 2023 code because we made changes in 240. 240. It's going to be in the general requirements. It's going to be in general requirements. It's not in small conductors, not transformer secondary conductors, not flexible cords, not standard ampere readings, not in the listing requirements, not in the thermal devices, not in selective orderly shutdown, ungrounded conductors. Somebody have it? Does somebody have it? Are you referring to? I agree with David, unless there's an 240.83C. Boy, I was on 21, so 83. 83's in which part? Oh, circuit breakers. Yeah. 83 is marking. So there's got to be one for fuses too, because those are 10K. Every circuit breaker having an interrupting rating other than 5,000 amps, and there has to be a similar one for fuses, which is at 10,000 amps. And what we did in the 2026 code cycle, we moved it up, I believe. I believe I can fly. I believe we moved it. Where did we move it to? Blah, 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 blah. There it is. Nope, that's not it. I can't remember where we moved it to, but we did something with that. I'm going to look for 5,000. There's a 5,000 amp breaker. Interrupting ratings. OCPDs specified in 240.7. That's what we did. It's in 240.16. 240.16 is in 240.16. Drum roll, please. 240.16 is in part 1. So we added 240.16 interrupting ratings, and we said overcurrent protected devices specified in 240.7 shall have an interrupting rating not less than 5,000 amps. And that would include the fuses. So you can't, we lost the 10,000 amp default for unmarked fuses. But that's okay. How do I do this? All right. Laurel said, David, you're referring to 408.9b. That's 10,000 amps. And then Steve says, I agree with David, unless there's an odd case of marked equipment rating greater than 5KA, AIR, that isn't the unmarked. I believe other inspectors already make this reference. And then there's the 240.83, Charlie. And we added a new 240.16. Woo! I love it. All right. So, I think, so my answer to this question, how far do we have to go? Well, we can look at the code, and we know the code has specific requirements for panel boards, switchboards, and switchgear. Also, industrial control panels, motor control centers. There are various areas in the code, but regardless of the code requirement, how far you need to go down depends upon the component you're trying to ensure has a correct interrupting rating or a short circuit current rating. That's going to dictate how far down you need to go in the system. Yeah, Steve, I caught the 10,000 amps. I figured everybody else did too. Okay, so that's my answer to that one. And I love the dialogue. That was a really good dialogue. And I'm really looking forward to that ECNM magazine article that has the examples. So I have an interesting question that came to me involving a code issue. I've been doing this for many years, and it was never brought up, possibly due to the old days of using the conduit and cable tray systems as grounding. But we have since not done that in many years. The question is, do you need an equipment grounding conductor on a motor control circuit to field devices such as start-stop switches and relays on a motor control circuit off the control power transformer on the integral motor starter circuit? Interesting question, because usually the field boxes for the switches are plastic and the contacts for the start-stop are plastic with metal screws for the conductors with basically no place for a ground. You essentially would have to screw a locking ring nut to the conduit with a ground lug to find a place to land the ground. I know the code mentions that a motor control circuit from the CPT is not considered a branch circuit, but not sure if this is relevant. However, There is nothing in the code that I can find that addresses this specifically for motor control circuits, but it may be simply implied that an EGC is needed. That is a good question. So, David Engelhart, where would you start your journey? This is our question. Let me do a Control C. I'm going to do a Control C, and I'm going to come back here, and I'm going to do this. Control V. Add. Oh boy. Edit text. Text color, I'm going to make it white. And I'm going to increase it to 24. Save. And how do I... Ooh. There's the question. Man. Oh, here we go. Jeez. I can't... Holy flypaper, Batman, I'm stuck. All right, so, hey, don't forget to like and subscribe. Amen. There's Laurel. Where's Laurel? Thank you, Laurel. I always take Laurel's advice. For some push buttons with metal nuts, you can connect the EGC to the screw that holds the contact block, but that is not always the case. So here's my thought process. What was not said in this question, it says start and stop switches and relays. Start and stop switches for motor control. Are we saying that there is no equipment grounding conductor? There's no green terminal on the back of those switches? Is that what we're saying, Dawn? I gotta find an image. There's a Siemens connector. I don't know if they have. I'm just on somebody's website. I'm on Grainger. I just found one of those switches on Grainger. Here's an Apple. I don't know. Do they have a back picture of it? I guess there is no place on. There's no place to land an equipment grounding conductor. Don says no. For some push buttons and metal nuts you can connect. Yeah, so that's an interesting. So now what I did was my thought process was I would go to Article 250. Where's my Article 250? I would go to Article 250. Our solution was to switch to the push buttons of all non-metallic construction. Yeah, that's a good question. Metal push button for control. Even the metal ones don't have a terminal. Here's an Allen Bradley. Allen Bradley has a flush head. It's all metal. And there's nothing on there. Wow. So, This is okay. So this question just got pretty serious. I thought so. My gut was I again, some of these I do homework on. I didn't think I was going to get to this one. It is past an hour, so I could use that, but I did allocate for myself till 1:30. I was going to go to 250, so I would have gone to 250, and it's in the hundreds. Where's the equipment grounding conductor? There's bonding. General requirements for bonding. You have bonding for communications. Where's 250.1 something? Cord and plug equipment. There we go. All right, Dawn is saying something. I think Ellen Bradley has a ring that you can add on the inside of the box for equipment grounding. It appears the original design was only for using these devices in metallic enclosures. Yeah. So you would need to be able to bond it, and I would go to. I would go to 250.110, I think it is. I'm in 250 and I can't remember. Is it 110? 110. Equipment fastened in place, fixed or connected by permanent wiring methods. Exposed, normally non-current carrying metal parts of fixed equipment supplied by or enclosing conductors or components that are likely to become energized shall be connected to an equipment grounding conductor under any of the following conditions. If within 8 foot vertically or 5 foot horizontally of ground or grounded metal objects that's subject to contact by persons. Now, if it's a plastic box, if located in a wet or damp location, if in electrical contact with metal, if in a hazardous location, if supplied by a wiring method that provides an equipment grounding conductor. Oh, if supplied by a wiring method. Well, the wiring method. Oh, if equipment operates with any terminal at over 150 volts to ground. So 120 volt push button wouldn't meet that. If supplied by a wiring method that provides an equipment. So if the wiring method permitted, except as permitted in 25086. Specific equipment fastened in place, except as permitted. I would go to 250. I don't know that I would go to 430 for the grounding requirements because Article 250 would apply. So if I'm required to have an equipment grounding conductor for that circuit, depending upon the voltage of it, the location, etc., then I would say if you're required to pull an equipment grounding conductor, those components should be bonded. And this question is a little bit more complicated than I thought it was going to be. So what I'm going to have to do is think about, if I think about an all, if I think about a all plastic application, because that's the point of this question. The point was that they're doing more with plastic boxes, etc., in these industrial applications. And he's saying, what is he saying? I don't want to put words in his mouth. Usually the field boxes for the switches are plastic and the contacts for the start-stop are plastic with metal screws for the conductors with basically no place for a ground. Now, this would be, the switches are plastic. So if everything is plastic, to your point, Don, you move to all plastic, then I don't have to, but I need to find the exception in 250 that says I don't need to bond plastic, which I know it's there somewhere. Because it says all metal parts have to be bonded, and that if there's no metal parts, then I don't have to bond anything. But if I have a switch or a push button that is metal, then I need to bond it. So I would go to 250.110 would be one of my stops. 250.112 would be another one of my stops. 250.118 tells me, 250.118 tells me what are the types of equipment grounding conductors. So if I just look at 250.109, metal enclosures shall be permitted to be used to connect bonding jumpers or equipment grounding conductors. Let me go to a general requirements. Bonding, 250.90. Bonding shall be provided, if necessary, to ensure electrical continuity and the capacity to conduct safely any... Oh, that's another one. So the other aspect of this, that equipment grounding conductor is there to facilitate ground fault currents. So if I have a metal pipe in a plastic box, wow, this is a good question. This is a really good question. I'm worried about fault current. I know that. I know I have to have all my metal parts bonded so that I don't have anything that a potential difference. And if I have a plastic box, I don't have to worry about it. So I'm not necessarily, if I have a plastic box and plastic components, then I'm not worried about difference of potentials because that plastic box is an insulating material. I'm more worried about a fault that may occur and being able to pull fault currents back to the system. So as long as they go all plastic, to your point, Don, then so foaming is in the house, and this is what I love when guys like Steve step up, smack you in the face, and look at you and say, "This is not a premise wiring," and it's not. 250.20B2, 250.20B2. 250.20. That's for grounded systems. This is for, I'm talking bonding. That's system grounding, Steve. What we're talking about, and here's what we're talking about. If when you have an equipment, the question is, do you need an equipment grounding conductor on a motor control circuit to field devices like start and stop relays, on a motor control circuit off the CPT, control power transformer? Interesting question, because usually the field boxes for the switches are plastic and the contacts for the start stop are plastic with metal screws for the conductors with basically no place for a ground. So all of those components are plastic. I wouldn't go to part 2. I would go to part 5, bonding, to determine what needs to be bonded. And it's going to tell you metal parts all need to be bonded. If it's not a metal part, then you don't need to bond it. If my push start stop switch is plastic, then I don't have to bond that either. But if I apply it in a metal box, now I'm going to have to bond things together because the metal box has to be bonded, and I have to pull an equipment grounding conductor, the whole bit. Here's what I'm going to do. I will draw out the diagram. That's what I am going to do. I'm not going to do it today, but I will do a session on this topic I'm going to try to identify all the different sections. Oh, Don Ganir. Oh, man. Control circuits are included in the Article 100 definition of premises wiring. That daggone defined terms again. Premises wiring. See how this is the mind of a good code person. Don went straight back to Mama, right back to the defined terms of premises wiring. Let's see what it says. First of all, what is a premise? Premises. Premises. The land and buildings located on the user's side of the point of demarcation between the communications, I gotta turn that off, between the communications service provider and the user. So that's the premises. Premises wiring system, interior, interior and exterior wiring, including power, lighting, control, and signal circuit wiring together with all their associated hardware, fittings, and wiring devices, both permanently and temporarily installed. This includes one of the following: wiring from service point or power source to the outlets, wiring from and including the power source to the outlets where there is no service point. Such wiring does not include wiring internal to appliances. Oh. So it doesn't include controllers, motor control centers, and similar equipment, motors, luminaires, appliances. So, control circuits. So, control circuits. This is weird because it says interior and exterior wiring, including power, lighting, control, and signal circuit wiring together with all their associated hardware. But it says that wiring does not include internal to appliances, luminaires, internal to, or internal to a controller. So if it is control and signal circuit, but if that control and signal circuit is, if it is internal to a motor control center, those are listed products. So if you have an MCC, so if I have an MCC and it's a listed product, then I don't worry about the internal wiring. But if I'm taking a box that has a couple buttons and I'm pulling a raceway to it, it probably does cover it because it's control and signal wiring together with all their associated hardware and fittings. Such wiring does not include wiring internal to appliances, luminaires, motors. I get those. Appliances, that wouldn't apply to like in my stove, all that internal wiring. Luminaires, motors. You know what that should say, Dawn? It should say such wires do not include wiring to internal wiring of listed assemblies such as appliances, luminaires, motors, motor controllers, etc. That is what I'm thinking. Anyway, this is going to take a little bit more of a discussion, and I'll draw it out, and I'll point out the requirements. So I would go to 250. I wouldn't go to 430. I would go to 250. General requirements for bonding. I would go for bonding. And we really have to understand why those buttons don't have a place for the Komargani conductor. So I've got to do more homework on this one. I'm going to do some more homework. So I see another question came in. Whoops. Sorry about that. Don Gannier, Steve Fromming. Oh boy, wait. Don Gannier, Carl Lewis. Control circuits are included. Okay, Tom, I was wondering, why do some appliances trip GFCI receptacles? Ooh, Carl. Lock and load, buddy. Great question. So here's the thing. Let's talk appliances. Let's talk stoves. One of the issues, so there's two things, two possible reasons, Carl. Three possible reasons. One is you could have a ground fault. So I'm just going to put that out there that I want to acknowledge that pretty much everything I've seen, my personal experience has been actual problems, except for one personal experience. Two, you could have high frequency currents. A lot of these appliances these days are using high frequency, variable frequency drives. And unfortunately, in some cases, I don't know what your background is, but from an engineering perspective, I don't know, when I used to do circuits, I did an amplifier circuit and things like that. Whenever we had problems, I learned all you got to do is put a capacitor in there, line to ground, and filter out the high frequency stuff. Well, when you design a product and you want to filter high frequency stuff, you should filter it to the neutral, not the equipment grounding conductor. But in some of these appliances, say, that are 240 volts, which is not what you're talking about. You're talking about 120. But if it's a 240 volt and there's no neutral, they filter it to the equipment grounding conductor. And any current that goes outside of the path, including these higher frequency currents, that would be ungood for the GFCI, driving compatibility concerns. Now, what manufacturers have done is, if you look at the response curve from a UL 943, I do have a PowerPoint slide deck. I have a slide deck. Distribution equipment, GFCIs. Circuit breakers. Oh my gosh, where is my GFCI? DC versus AC, SCCR, single line. I need to do a search for GFCI. I like to install my GFCIs. I need to do a filter and put the type as file type, crate tags, kind, PowerPoints, presentations. All right. I should be able to find a good example, and I'll show you what I'm talking about. So basically the issue that you may see in some of these cases is you have high frequency currents, right, flowing. And the high frequency currents can cause the GFCIs to trip. So, I'm hoping that this is not just code changes. It is. Sorry. I'm looking for, there is a curve for GFCI protection. And it shows where that let go threshold, and what manufacturers are doing, Carl, is for those 120 volt, 15, 20 amp type of applications, and even higher, they're moving the response times up and hugging the the curve. So adding a slight delay in there, but still being able to pass 943. And, oh, here we go. Fundamentals of GFCI. No, that's not it. Gosh darn it. Yes, here it is. Found it. Found it. Ba-da-da-da-da. I found it. All right, so if you see in this curve, you have the typical Class A GFCI response time, which is really fast. Now, that response time is looking at a 60 hertz, but also if I have higher frequency currents. And there's the maximum permitted by UL. You see that red portion of the curve. So what's happening because of these leakage currents, and a lot of the leakage currents are temporary in nature. So when we design circuits, and I try to tell my message to anybody out there who's designing stuff, if you're going to filter anything out, don't take it to ground, take it to a neutral. And the argument on some of the appliances is there's not a requirement to pull a neutral to the appliance. And if you don't have that neutral there and you have no use for it, when you start to filter things out, where do you filter them to? You filter them to ground. And they build a ground plane inside there and they put their capacitive coupling and all that good stuff over to ground. Well, that is ungood. So, and I can understand that from a design perspective, a design engineer arguing with marketing and sales saying, we need to require pulling a neutral to our appliance because I'm going to be filtering off these higher frequency ground fault currents, and I don't want them to be a ground fault current. I need them to be a current that goes over a normal path, which is the neutral, the grounded conductor. And you're going to lose that battle every day of the week, twice on Sunday, because they're going to go, you mean to tell me that I need to require a neutral conductor and none of my competitors need to? So high frequency is one of these aspects. And the first place that I saw this years and years ago, we had an issue where we had a 30 milliamp ground fault that was tripping. And what we learned was that there were a lot of these power strips, cheap power strips that were connecting. They had MOVs. They had a power strip, but they were a surge suppressor. And the MOV was connected to the ground instead of the neutral. And there is a neutral pulled. I mean, you have a hot and a neutral. Instead of shunting the voltage, the currents to neutral, they shunted them to ground, and it would cause the 30 milliamps to trip. So we had to put an intentional delay in that 30 milliamp ground fault circuitry inside the breaker to ride through these blips. And when we would see the blips is when you would have a utility ring wave from capacitor switching. The capacitor would switch, you would have a ring wave, and then boom, the surge device would go off, and boom, the breaker would trip. So then we had to add this delay, but we also had to figure out how do we change the standard for surge devices to not shunt to the equipment grounding conductor, but rather shunt to the neutral. Now, the appliances have similar issues. If you're not pulling a neutral, then where are you going to shunt to? You're going to shunt to the equipment grounding conductor. Now, another challenge that we saw in the industry, that's a documented issue that has come up at the code panel meetings. You take an appliance, and one of the steps in the manufacturing process is what they call, I believe, a burn-in. And it's to expend materials off of the, like to burn off, say you put an oil or something for shipping or whatever, and they want to burn that off. They'll do that when you first energize the appliance. Well, that puts a 60 hertz current over the equipment grounding conductor, and that trips the breaker. So when that occurs, and when we know it's an appliance like that, it's like, all right, guys, I mean, you could put it on a standard breaker, energize it, burn that off, put put a GFCI on, and now you're into protection mode. I don't know any other ways around that. Even whether it be a receptacle GFCI or a breaker GFCI, GFCIs are GFCIs, they respond to current going outside the path. And they're there to protect the human body based upon the human body's damage curve. So those are the three things that I'm aware of. One is a true ground fault. The other is high frequency. And in my opinion, it's that leakage current that's going to the equipment grounding conductor and not the neutral. And it should be going to the neutral because there is no neutral. And the third reason is this burn-in that I'm telling you about. And that's a process for specific manufacturers for whatever reason. So that's sort of the background that I know about. I'm not familiar with anything else. Those are just the things that I know. Oh my gosh, I got to turn my volume on. Steve, meant to say less than 5K. Okay, I missed that. There's Carl. Hey, Tom. I have David Engelhart. Who else had a Tesla solar roof advertisement disturb this event? Tesla is something else. Steve, some appliances trip because of the shoddy workmanship of the building of it or installation wiring that isn't detectable until it's installed and connected to the GFCI, one strand of unkempt wire. Steve, I would say here's the other issue. And we saw this in the change in Article 422 for vending machines. They put a GFCI requirement in Article 422, 422.5 for a vending machine in the cord. And they changed the standard because vending machines get moved from place to place to place to place. You throw them on a truck, you take them off the truck, you set them here. When someone says, hey, I'm going to move that over to this store because that guy's no longer going to pay rent for that, you put it on a truck and you put it over there. And in that moving, it is not necessarily that the manufacturer of the vending machine did a shoddy job. It's the fact that you've been moving it, and you can't even blame it on the movers. I mean, there's lots of things I like to blame on movers, but that might not be one of them. So you're dealing with things that are designed to move. It's not like a lighting fixture. Well, a lighting fixture does have to, you go to your supply house, you have to take it off of the box, off the thing, whatever, the shelf, and it probably was in another box. It was on a shipping container and all that jazz. But you do have to think about all of the different things that could happen that are outside of your control. A GFCI is a police officer on duty 24/7, 365. They don't sleep. Current goes outside the path, you're going to let you know about it. Carl Lewis, I'm asking because I'm a new electrical engineer in MEP construction. Excellent. Welcome to the industry, Carl, and it's great to have you. And thank you for speaking up and asking questions. That's a good thing. I would say, Carl, work with your suppliers. If you buy, well, I'm sure that that's all you buy is Eaton equipment. I mean, there is no other manufacturer that I would trust more than Eaton. I'm just saying. I don't know why. It's just like a thing of me. But work with your supplier. They may be able to tell you what to stay away from, what are common areas that they're seeing. Every manufacturer is going to be a little different. We've made changes and tweaks to our GFCIs that I could tell you, even our AFCIs in the AFCI history. I mean, I could tell you back in the day, in the branch feeder days, everybody remembers the Miley vacuum, the treadmill issues. My gosh, that was back in the, late 90s, something like that. But when you go through these scenarios, you get that feeling for what where there may or may not be issues. So, or concerns or challenges, and even troubleshooting to say, hey, how do I troubleshoot this? So, but from a design perspective, it's really great to stay on top of understanding all these details. And I appreciate you being a part of the program. Steve, fantastic. Hey, thank you, Steve. You're the man. Love you, brother. I've heard of burning off. Yeah, maybe that's what it is, burning off. In places for oils and moistures to avoid nuisance tripping. I've heard of burn. Yes, it's burning off, not burning in. Don't make sense. Burning off. You're burning off these materials, and it's because the appliance. I've heard people, I don't have an opinion on this. I don't know anything about the manufacturing process of appliances. I don't make an appliance. I've never visited the manufacturing facility for an appliance. It might be good to get Greg Wazinski. I might reach out to him or no, he's heating and ventilation. I need an appliance guy. I might reach out to, see if I can't reach out to some appliance manufacturers and try to get them on the program to discuss. Maybe during Shock Week. Shock Week. We got Shock Week in May coming up, and I've got to start recording my sessions for Shock Week. So stay tuned for that. And if you have ideas, go to shockweek.com. www.shockweek.com. And I am soliciting input for this month. This May is Shock Week, and I play those videos the last week of May. But I will try to reach out to an appliance manufacturer and maybe even try to get Greg. I think Greg is Aham, I think. I think he's a heating and ventilation guy. Which I'm talking about. I just put a heater in my garage, and this speaks to this other circuit. So Dawn, I don't know if Dawn's still out there. So I put a heater out in my garage, and I ran Raceway. I put 3/4 inch conduit to it. I believe it's a 50 amp circuit. I can't remember what size conductor I used. But I was debating on, do I pull a neutral, because I was going to use the Raceway. Well, I went to a Lowe's to buy the fittings. Like I bought an elbow, a 90 degree that the side of it comes off. I bought a few fixtures, and when I looked them up, it says they were not listed as an equipment grounding conductor. So I had everything else in there, but those components were not equipment grounding conductors. So I pulled it was an insulated green conductor throughout the entire Raceway, because where my fittings were connecting and all of those terminations, those couplings and stuff, I didn't have many of them, but I had an elbow. I came into a box with a flex. Then I bought the right connector for that. Then I came out of there and I went with a straight piece along the wall, and I had an elbow going up towards the ceiling. I had another elbow at the top. No, I didn't have an elbow. I had a box, I had a metal box, pull box. I put a pull box up there, and then I went straight over, but a couple of the fittings were not listed as equipment grounding conductors. So I pulled a bare copper conductor. I don't know why I even brought that up, but I meant to say that and talk about that when we were talking over there. Anyway, thank you, Steve. Appliances. Appliance needs compliance. Say that 20 times. Right, Robert? Nihad, I think Greg Wazinski is the Aham. Oh, he is Aham. Okay. He is Aham, not HVAC. Yeah, maybe I'll go grab Greg. I think he might be, Nihad, it just seems like Greg would be a guy that would be willing to sit down and chat. I mean, we have our disagreements, but I think we have more agreements than we have disagreements. Robert, you ran tubing, not conduit. What did I run? What's the difference? See, I'm not a tube guy. So I didn't run conduit? What's the difference? I thought it was conduit. It was Raceway. All conduit fittings are required to be listed, and all listed fittings are listed for grounding and bonding. Well, Dawn, so here's what I did. I went to Home Depot, Lowe's. Lowe's. Because Lowe's knows. I'm going to go to Lowe's. We're going to go to Lowe's together. Let's go to Lowe's. And I bought, you can see what I was looking for. I'm looking at, I think I'm going to put a fireplace down here. A ventless, and I'd love if anybody has any history or knowledge about ventless fireplace, like that Bluegrass Living one there, something like that in a basement. I want to bring the temperature up in here so I don't have to wear this sweater. But in any case, conduit elbow. 3/4 inch conduit. Oh, no, this is the one I bought right here. So it's a Sigma Pro Connects 1/2 inch 90-degree EMT die cast zinc pull elbow conduit fitting. That's what I bought. There's 3 of them in stock in Steubenville, Ohio. So when I click on this, it says it has UL right there. I see the UL mark, so it's UL listed. And then when I go down here, makes turns, specifications, height, features, EMT. I'm looking for equipment grounding conductor. I looked for EGC. It has a UL safety listing. Width, type, EMT, safety, UL listed. It is UL listed. Where is it that it said it was not listed as an equipment grounding conductor? Rigid metal conduit compatible. Liquid tight conduit compatible. No. Tubing. There it is. Robert. EMT. Electrical metal tubing. Oh my gosh. And it's not See? This guy can be taught things on this class. So thank you, Robert. You are a wealth of knowledge. So, die cast zinc. I don't see it. Dawn, you're 100% correct. I don't know what the heck I did, but I did a search. Product is UL and CSA listed for dry location applications. So maybe I did not have to pull the equipment grounding conductor. But I did. Sigma connects elbow, it's 90-degree bend, run EMT conduit where it is. See, EMT conduit, so look, it should say EMT tubing, where it is essential, or raceway, where it is essential to make the tight turns, which is what I had. The die cast elbows offer set screw. All right, so I guess it is probably listed as a. I don't know why the die cast zinc caused me to concern, but to your point, Dawn, it is listed, so it is probably listed as a raceway. I probably did not. That was one, and the other one was the, which I did not end up using. Oh no, I did use the zinc-plated steel coupling. And let me see if that says UL listed. Yeah, UL listed for dry locations. So, see, Dawn? I did an overkill. I spent probably a little bit more money than I should have. Look at that. EMT is tubing, not conduit. I love it. Steve, in all solid fuel or fuel gas appliances, unlike other appliances, the instructions themselves are UL listed. And this makes them able to be found even if very old. Oh, interesting, Steve. Very interesting. I like it. All right. I gave myself till 1:30. Oh. I gave myself till 1:30, and it is 1:45. I have to see if I'm missing a meeting. I don't think I am. I think I can. I think I can. Oh, I am coming up on one right at 2 o'clock. So I got 15 minutes. All right, everybody, listen. Yes, Dawn. Call the push button. Issues you finish. Yes. Dawn, I do. You have my number. I'm not sure if I have your number, but give me a call. Laurel, thank you. Thank you for everything, Laurel. I really appreciate your engagement, and I thank you. Where's his name? Carl Lewis. Thank you. Hopefully, I got your last name right, Lewis. Thank you for joining in. Nihad, let me talk to Dawn first, and then because I got about 15 minutes, 2 o'clock. So let me talk to Mr. Ganir first, and then we can chat. All right, everybody, I'm going to sign off. Thank you for everything that you do for the electrical industry. Thanks for what you do for electrical safety, and remember to please stay safe and healthy. All right. Thanks, Carl. Take care.